Well, thank you, Heather, and thank you all from Hazard Control Technologies for giving me this opportunity to share information for all of you around the world today. Hello, and we hope you're having a wonderful day, as today is an awesome day. It's a day that we can share knowledge, share experiences that can lead to protecting people, protecting property, and protecting the environment. Again, as Heather stated, if you be so kind to put your email address and name and information within the chat box, they will be happy to send to you a copy of the presentation today and any information that you may have. Feel free to reach out at any time. Also, as you hear things or things come to your mind today that you would like to talk about so you don't forget about them, you can add them into the chat. We will have opportunities throughout today, again, to answer those questions or discuss them. And certainly, we will finish up with a period of time that we can talk about things that you want to talk about. So once again, thank you for this opportunity and thank you for joining us today. We're going to be talking predominantly about power generating facilities, the fire hazards, the solutions, and with goals of increasing one's awareness. As we recognize throughout the world today, the hazards continue to emerge. We're faced with new hazards, and some are faced with the challenges of managing those hazards. We're going to talk about, again, the hazards. We're going to talk a lot about the encapsulator technology today. Detection, correction, and prevention is a focus. Specific hazards within the power generation area, and certainly one of the most advantageous is the resources that are available to, again, help us protect harm from people, from property, and yet be environmentally responsible. Our objectives today really is to understand the common hazards within a power generating facility, to better understand the encapsulator technology, to understand and describe some of the various fire and vapor hazards that are common within the industries, and again, most importantly, to answer your questions. Always remember, if something pops up in your mind later on, we are resources that you can reach out to discuss. But again, please do use the chat so that you remember the questions you have or the conversations you like to have later on. As we know, within the steam and electric power plants, there are various types of plants and facilities. There are some of those that produce the steam and electricity through the use of biomass. Biomass, whether it's wood products, waste wood products, the pellets, and there are various types, but they're all derivative basically of wood. Coal is certainly a significant one that has made the world great. Coal continues to be used throughout the world, and there are different ranks of coal, and each with some of their specific hazards and methodologies, but it is a very widely used fuel yet today. We continue to see refuge. Some call them municipal waste plants, some call them trash plants. They're basically simply taking waste. Instead of putting it in the earth, they're using it for the creation of steam electricity. Gas is another very widely resourced fuel for power and steam facilities, whether they're combined cycles, conventional. Gas is, again, widely used. Nuclear is still out there. Nuclear's been used and continues to be used. We see the growth within the solar as a form of providing of energy. The wind is another method of providing energy. Water, namely hydro plants, again, are all common types of steam and electric power plants throughout the world in operations today and continue to be built. We are beginning to see a continuous increase in the world today with the lithium ion, as well as the energy storage systems, a means to take and store the energy for consumption at a later time. A very big and very ongoing activity, certainly with its own fire and explosion hazards. Hazard Control Technologies has had in the past and continues in the future to offer these webinars on various hazards, including energy storage. And again, we encourage you to take advantage of those learning opportunities that are held every 2 weeks. And again, reach out if you have any questions at any time. What we do understand from history, and history is a teacher to us, is the most likely things to happen in power generating facilities are fires and explosions. Those are the areas that we continue to see occurring. They can result in harm to people. They cause property damage. They cause business interruptions and environmental impacts in many of those areas. So they continue to be a significant hazard and thus significant concern on what's taking place in the world. The hazards range from high voltage to high temperatures, to high pressures, to fast rotating pieces of equipment, to fuels, whether they're solid fuels like coal or biomass, liquids, gases, and metals. There are lots of different fuels out there that certainly can impact the fire and vapor hazards within any given facility on any given day. Another one is a topic that is I term unfamiliarity. As we continue to see the age differences as people retire, there's a tremendous loss of tribal knowledge, information, how we did what we do so that we don't have the things that we don't want to happen. And we have new coming in that don't know what they don't know and are looking for methods of learning, but there's just a tremendous change and creation of a gap of knowledge. And sometimes we don't recognize the hazards. We don't predict it. We have the thinking, oh, it's never happened here before. Oh, it won't happen to me. We're better than that. And yet we see those situations happen about everywhere at any given time. So our theory is, let's learn, let's generate the awareness, let's detect, let's learn to prevent, and then control. Again, a lot of our time today will be spent specifically on the hazards that are relating to the fuels in the various types of power generating facilities in the world today. As we look at the very big picture, as we talk about steam and electric generating facilities, while there are many types of facilities and many different components and processes and systems and hazards within each of those facilities, there are also many excellent solutions to detect, to prevent, and to control. And we will cover a number of those throughout our next moments together. As we begin to see today, we hear about the conversion from the traditional vehicles using gas and diesel to more of a focus on the growth in the electric vehicle area. And these electric vehicles, we have to remember one thing: somewhere they're getting their power. Their power may come from coal, it may come from nuclear, it may come from gas, it may come from hydro, it may come from energy storage systems. But somewhere all of this is feeding into that need for power, the need for energy. And as we begin to look at vehicles, just like we look at electric and steam generating facilities, we quickly realize that there are many classes of fire within any of these facilities. There are Class A materials. In a vehicle, they're the plastics, the rubber tires. In a power plant, they can be the insulation, they can be the papers, they can be many different Class A materials within any given facility. And then we dive into Class B, and we realize whether it's a vehicle or a steam electric generating station that we have lubricating oils. And in generating and steam generating facilities, we have transformers that have mineral oils within. There are a lot of different Class B fuels that exist out there. Some of them are under significant pressures that again accelerate and intensify the hazards that may exist today. We also recognize that just like a electric vehicle, that within steam and generating facilities, we have energized equipment. And it's something you just can't go flip off a switch and say, hey, the power's gone, we don't have that Class C hazard anymore. That's not a true statement. As we look at electric vehicles, there is no switch. There is no way to de-energize it. So there has to be a perception that treat things as they are energized. And the same in many parts of the power plant. There are things that are energized, and you have to treat them as if they are until someone who is qualified can verify otherwise that's not. There's combustible metals. In vehicles, there's a lot of magnesium components, as an example. In power plants, there may be titanium. There may be other combustible metals, even within electric steam generating facilities and that. And today, even though there's no recognized formal classification of fire for it, there is a hazard of its own. And we call those lithium ion. Lithium ion batteries, as an example, contain multiple classes of fire and have their own unique characteristics that bring a different dimension to the protection of people, the protection of property, and being environmentally responsible. So like electric vehicle, power plants often have all of these, or certainly a good combination of these types of hazards or these classifications within the facility. Over the years, we've talked about Class A use of water. We've talked about carbon dioxide being used for Class B and Class C fires. And we've talked about dry chemical as for Class A, B, and C fires, or B and C fires, depending on the type of dry chemical. And dry powder, while it's recognized for the use on combustible metals, there are foams out there, different types of foams. And today we even have a highlighted awareness of the health-related issues with foams. And there are wetting agents that are also been developed that are being used today. But there is one agent that has a track record, a proven history, tested by many independent people as an agent that can be used on all the classes of fire, some with some specialized training and knowledge, but certainly is an agent that has proven unique, but yet most successful in protecting property, protecting people and their health, and being environmentally responsible. And that is the F500 encapsulator technology. So we find sometimes when we talk about unfamiliarity, we begin to say, oh, geez, look at what people do. Humans make mistakes. That's real. We make mistakes. And while we have maybe a fire in a coal and somebody wants to grab a carbon dioxide extinguisher, or they want to grab foam, or even dry chemical, it's realized that those agents are not going to suppress the fire, control the hazards. And in fact, some cases, the methods could actually cause the problem to worsen. So we have to continue to be aware that the more things we put in front of people, in some cases, the more choices they have, the more likely they are to err and take the wrong thing for the wrong purpose and cause harm. And sometimes you can say, if we have something that works so well on so much, why not focus on the use of that? So again, these are thought processes that owners and operators and authorities having jurisdiction will all struggle through at one point or another. Well, let's talk for just a few moments about encapsulator technology. Well, we recognize in the chemistry of fire that early on we learned about the fire triangle. And we learned that in order to have a fire, you had to have fuel, you had to have oxygen, you had to have heat, and yeah, rah, rah, rah. We knew when those three things together, you could have a fire. Then we began to introduce technologies that suppress fires. And we learned that one can do one or the other, but all of a sudden we realized, how do some of these agents really work? And from that, we realized that the chemistry of fire is very complex, and that it's really a tetrahedron. It's 4 items. It's the fuel, it's the oxygen, hey, it's the heat. But now we have that chemical reaction that occurs where we're getting in a very specific molecular type of thinking, that if we take away any one of these and keep it away from the others, it's a means to prevent fires. And we also realize if we take one of the away from the others, it's a method to suppress fires. And so when we look at extinguishing agents, we generally look at something that can do 1 or 2 of these. But it's not often that you can find something that can work on that molecular level and work on all of these simultaneously and on all the different classes of fire. And again, removing one of the barriers that people make human mistakes. The encapsulator agent has been around for well over 20 years. Hazard control technologies has the patent since around 1996 or so. It's recognized as a water additive agent that has extremely superior cooling properties. It can work very well in the Class A, the Class B, the Class D, the lithium-ion battery fires. It works well on pressurized and 3-dimensional fires where many other agents will not. They will not be good. Sometimes you get lucky, but do we really want to base protecting people and protecting property based on luck? Encapsulator agent is commonly known as F500 encapsulator agent. It's, again, a very environmentally responsible agent, and it does have a UL listing for the Class and B side. It really is a type of water additive. And if you're looking for a standard, the National Fire Protection Association has a standard on water additives. It's known as NFPA 18A. And 18A has, in its most recent edition, has the testing and the protocols and the methodology, how you validate the spherical micelle test and the encapsulator technology. So there is a very recognized means now to evaluate, to test, and it is a worldwide recognition in those areas. It does, again, work on the molecular level. It works on polar and nonpolar solvents, hydrocarbon liquids and vapors. And again, it's just not a fire control. It also can be a vapor, fire and vapor. Something, again, that is often a rare thing.
Encapsulator technology. The next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
As magical and mysterious as this may be, it's very simple. It works. And there are decades of history and cases after cases and independent laboratories that have come to the same conclusion. It's a very effective fire and vapor control agent. But it's new thinking, it's new technology, but it works. It works very effectively. You know, over the years, water has become the more conceptual, the more traditional fire extinguishing agent. Oh, it's readily available, it's relatively inexpensive, and we'll just put water on the fire in hopes that it will have the cooling capability. The hazards today are much different than they were yesterday. The hazards today will continue to accelerate as our needs for power continue to change and continue to grow. But the F500 encapsulator agent is mixed with water. It is a true water additive. And there are different techniques of mixing it, whether it's batch mixed in a tank of water, whether it's inducted into the water, whether it's introduced in different technologies. At the end of the day, when it's in the water and added to it, it can be a wonderful means to mitigate, control the fire and the vapors, and again, make a difference in the protection that one is providing in that. While I'm not going to go into a lot of details, this is available to you, and we will be happy to discuss in much deeper of the science behind it. But as an individual who have been in the industry for many decades, I can attest to you my personal experiences as well as case studies of others that it is truly effective in many areas, and it does make a difference on the human performance and the human intervention that we're faced with today. The capsulator agent is that droplet basically creates a circuit to reach in and grab the heat and drive it into that internal portion of the droplet. And you can see through demonstrations, you can see through live case studies, you can see through independent laboratory results that it does it more effective than anything. That the heat reduction is so quick, so fast, so good. And that as well as it's just as much better than just using water plain alone in so many different areas. We also have recognized its ability to encapsulate vapors. Therefore, those vapors can be encapsulated, they can be rendered non-explosive, non-flammable, non-combustive, and at the end of the day, that can make a huge difference on protecting people, protecting property in so many different areas. And we just think about today the very concepts of human health and how We are driven to wear self-contained breathing apparatus. Just like during COVID, we were driven to wear masks. Well, encapsulator technologies can also control a lot of these vapors that are hazardous and again, improve the quality of life for everyone. F500 encapsulator technology, again, it has some mechanics that are just tremendous. The surface water tension reduction. It saturates through the coal, through the biomass, through those materials to capture the surface area, to increase the penetration into the pores and into the material better than anything, including water. It has that rapid heat reduction. In just seconds, it can reduce the temperatures and absorb it many more times than plain water, and yet provide a burn back resistance. It creates the chemical cocoons around the liquid and around the vapor. Therefore, the material is non-flammable, non-combustible. It interrupts the free radical, and that's a big one. Remember, we're talking about working on 4 sides of the tetrahedron and doing it simultaneously. It has that ability better than anyone to interrupt that free radical because it works on a molecular level. As we look at different agents out there and we relate them to where do you go to get knowledge, we know that NFPA is the world's resource for knowledge in fire and life safety. NFPA 18 is a wetting agent standard. It provides guidance, information, testing, and therefore about surface tension reduction and heat reduction. NFPA 11 addresses foam. It talks a little bit about surface tension reduction, about getting a blanket of bubbles across a liquid or across a surface. It tries to temporarily separate the fuel from the oxygen to smother the fire, provided that that blanket doesn't get interrupted by somebody walking through it or hose line or whatever. Or even on 3-dimensional fires, it doesn't work very well because you can't maintain that blanket very long. It's actually, it's counterproductive to heat reduction. And it's something that you constantly have to keep maintaining and keep adding. And again, today, there is a continued growth and work concern over the human health of foams that may have fluorine that may ultimately impact human life. NFPA 18A is a water additive standard, and it very specifically calls attention to spherical micelles and encapsulator technology. We realize that it talks about the surface tension reduction and the encapsulation of the fuel and vapor molecules so that they're not ignitable and they're not flammable. It talks about the heat reduction, the mechanisms of the thermal conveyance and the water droplets and the tremendous ability it has to cool and to do it very, very quickly. And it interrupts that free radical. And again, it's very driven on the molecular level, and science brings us wonders. It brings so much good to us. The F500 encapsulator agents, again, I call attention to NFPA 18A because it really provides the testing criteria, it provides the methodology for this technology on a global and very broad area of hazards that we face today. It can be used on Class A fires and Class B fires and the 2- and 3-dimensional fires that many agents don't work well on at all. Sometimes it's by pure luck. It can be used on the Class K or the Class F fires. It's used for flammable liquid spills. Some have been very effective of using it on a spill to encapsulate the fuel And therefore that it ends up not only being of advantage that they don't have a fire or explosion, but they also uh, remediate the soil so they don't have the high cost of dealing with that. Today, we know, it's known today around the world that the only agent that has proven ability to extinguish and control lithium ion batteries without reigniting them is the F500 encapsulator technology. That's a very driven and very broad knowledge base by many who have tested it, and have used it in real life scenarios. And yes, power generating stations do have batteries, and there are today with the continued increase of solar and wind, the need for more and more energy storage capabilities that employ the lithium ion technologies, where the fires and the vapor hazards are tremendous. So let's talk a little bit about some of the fire hazards within a power generating facility. Recognizing that in a proactive world where we want to be, we want to detect these hazards. We want to correct those hazards when they can be corrected, and ultimately focus the greatest amount of our time in the prevention of fires, the prevention of explosions, the prevention of harm to people and to property and to business interruptions. Because as we recognize, when things are going well in a power plant, they are giving life. There are people that are alive today solely because they have to have electricity to be alive. They may be on a ventilator. They may be in some type of an intense surgery. They may be in a situation that in the absence or the loss of electricity, their life could be ended. And yet we rely on our smartphones. And to operate smartphones, you have to have electricity. You have to be able to charge them. And everything we do today is fundamentally based on the availability of energy. And when we take that energy away, even for a brief second, we can take life away. We can take away and interrupt a business success and sustainability. It has become such a need to have energy whenever we need it, wherever we need it. And yet we know that these hazards are significant, and in a split second, they can take a life away. They can burn down a property. They can interrupt a business. They can cause a significant environmental impact. So our need continues is, how do we do better in the protection from these hazards, as well as when these hazards do go out of control, how are we prepared to respond to them? And do we have the equipment, the knowledge, and the technology to address it, to mitigate the things that are already occurring? When we look at power generating facilities, there's a lot of hazards. Just to throw out a few of them, there's the fuels or the bulk storage. Coal, biomass are examples of it, of the fuels, the bulk storage of these things. Even to degree, energy storage systems today, the bulk storage is the lithium ion batteries. There's combustible dust, whether it's biomass, whether it's coal, whether it's the activated carbon being used for environmental mercury control. All of those are examples of combustible dust. And when those particulate solids become dust, and the dust is not well managed, it can become a flash fire, an explosion, or a fire hazard. We know that we move products. We're moving gas. we're moving coal, we're moving biomass, we're moving many different types of materials throughout the facilities. All of those are potential hazards in the handling, the transfer, and the processes to which they're being used in. Pressurized oils, the lubricating oils for the turbine, the lubricating oils for the boiler feed pump are just a few examples that when they're out of control, that can be devastating. It can really harm people and interrupt those. And they are three-dimensional fires that are very difficult. Transformers are all around us. Transformers are used to step up voltages, step down voltages, move things around. They're where we work, they're around where we live, they're around where we play. They're everywhere. And again, the other area we're beginning to see is the growth in the energy storage systems that are also could be in your backyard someday. So these are some of the common hazards that exist out there. Let's talk a little more specific for a few moments on bulk materials. Example is coal. Whether it's coal or it's wood or biomass, we know generally there's a significant supply. It's being brought in from somewhere, and that significant supply is a huge fire hazard. And it can be a flash fire or even a explosion hazard under given circumstances that has to be managed. It has to be proactively managed so you prevent fires. You have to have the mindset of detecting them and then knowing what to do to control the hazards when they get out of control, and have the equipment, have the knowledge, and have those resources. This is a video of just a little bit of coal that occurred in a facility a number of years ago. In this particular situation, there was coal that accumulated on a structural in the area between the turbine generator and oils.
Hey, Bob, you need to turn the volume down so we can hear you talk.
And fortunately, somebody pulled out their camera and videotaped it. But as this continues to grow, what do we do? What do we do? What do we have to work on? And over time, the fire continued to grow. Ultimately, it was death. Ultimately, it was the loss of generation. The business is severely injured. Are happening with just a little bit of coal on a beam, and no one really was prepared for it. No one detected. They didn't know what to do. And as you can see, the fire has spreads across units. And everybody's
Hey, Bob, I don't know if you can hear me. When the video is playing, the sound is so loud you can't hear you.
This was
Ой, осторожно, бо оно взорвется дальше.
And I appreciate it because I think today this is the why, the reason that you're here today is to learn and to share. 9 were injured.
Hey, Bob,
Yes, sir.
can I just interrupt you for a minute?
Sure.
The sound on the video is so loud that we can't hear a word you're saying as you're discussing the video.
Okay.
So I don't know if you can crank the sound on the video down a little bit.
Yeah, that's what I was trying to do. Well, with hopes you saw the video, and I just will kind of recap the video is that was just a little bit of coal on a structural beam between the turbine generator and the steam generator building. And the fire began to grow and developed, and no one really knew what to do. And as things developed, there ended up that the fire spread across the entire buildings. There was a life loss. There were people injured and harmed. They lost business interruption. They had significant property damage. All the things that you never ever want to happen happened with just a little bit of a hazard that wasn't detected, wasn't controlled. No one knew what to do, was prepared for. So sometimes you begin to say, geez, have we been lucky that it hasn't happened before? And the point being is, think about the unexpected, prepare for the unexpected, so that you don't find yourself in a situation that just a little bit of something going wrong ended up so bad in many areas. Everybody hearing me okay now? So when we talk about fuels, as we talked about coal and biomass, they're wood-based. Petcoke is another type of fuel that is being used. It's a derivative of the refinery businesses. Activated carbon, there are places that are using briquettes. There are refuge where they're using all kinds of different trash coming into facilities now, and the waste and so forth. The hazards are petroleum based. Many facilities have very large storing capacity for fuel oils, storage capacity for lubricating oils, for mineral oils such as in transformers, for diesel fuel. There's gases and vapors from natural gas to propane to hydrogen, and even including carbon monoxide. And then the other big bulk, again, think about energy storage today. Think about the lithium-ion batteries. It's not just the single little battery nowadays, it's multiple batteries in a given situation. And then one common enabler with all of these different hazards is the ability for F500 encapsulator technology to control the hazards. That is the one common factor in all of this. When we talk about fuels, we talk about storage. Storage can be outside in large piles. Some are inside barns where they're being protected from the weather, whether it's the wind or the rain. Some are inside enclosed domes, a little bit more restrictive in access. But storage is an area that many fires do originate at, in bulk storage. And it can be difficult without good management practices, without the preparation for the emergency preparation that includes not only the encapsulator technology, the equipment, and the knowledge. It's the training of people that becomes very important. They happen in transfer situations, in chutes and in bends and in hoppers and in silos, in areas that the material is temporarily stored in. Sometimes you have stagnant material in there. Sometimes it's stagnant because of loss of operation, or today with cycling of loads is you may be running one moment, next moment they say, hey, you're offline, market doesn't need you. And now you're stuck with material being stored someplace it's not intended to be very long. The transportation, the video you're seeing live at the moment is loading out a ship with a biomass product. And again, it was something they never expected would happen. So fires happen in transportation on conveyors, transporting it on, off, or in ships and in barges and on the rail and the mobile equipment handling it. These are all real and likely fire scenarios in any given facility. So those hazards have to be managed. They manage those hazards from the moment it arrives all the way through the handling process until it's gone. And those include fire. The dust has to be managed, whether it's wood dust from biomass, whether it's coal from coal dust, whether it's combustible metals from the magnesium or the titanium or other combustible metals, shavings and powders, to the activated carbon. Those are just a few examples of combustible dust that have to be managed. If not, they become explosive and they cause harm. And the gases, the pressurized liquids like lubricating oils, all can be, at the end of the day, explosive and ruin the whole day when things take place. So these are just the continuous hazards that are out there. And again, fires, explosions do happen. The insurance companies will tell you it's amongst their greatest losses in power generating facilities. Stockpiles, again, whether it's inside of a building like a dome or a barn, or outside in the open, those stockpiles can spontaneously combust given time, given wind conditions, given the sunlight, which just popped out from the rainbow, the moisture, the ambient temperatures, and how we go about moving coal or biomass are all factors that influence the stockpile hazards that can be faced with. Where we put that combustible material, whether it's, again, biomass or coal or wood shavings or sawdust or whatever, in the bins, the hoppers, the bunkers, the silos, that some of the hazards we're faced with are in closed spaces. Many of them have stagnant areas where stuff gets trapped in it. You've got the material sizing that you get the fines, and the dust traps on structural steel and traps in areas that they don't get attention in cleaning and removing. And then you have the inactivity, which is something that's increasing now, a lot driven by the current market conditions and the thought processes for running the dispatching plants. And then you have cavities, hollow areas within the bulk material that basically can collapse and cause an explosion or collect things like carbon monoxide and other explosive gases that can ultimately result in harm. In the perfect world, on the right is a mass flow design. It's intended that the material flows through the bunker, the bin, the silo, the hopper without any issues. The real world is, on the middle and the left are probably more realistic conditions in the world today, where the materials take on more of a funnel flow. They go in, straight down, and out. The material tends to build up on the sides. And therefore, you have to have a management practice that allows for that stagnant material to be detected and to be removed on a periodic basis so that it doesn't become the fire hazard. It doesn't become the explosion hazard. It's something that you can manage through processes and procedures, but yet you still need to be prepared when humans fail, that you can react to the situation and safely and healthily deal with it. One of the things that we've known over a long time is one of the methodologies to detect spontaneous combustion, again, whether it's biomass or coal and other products, is through the monitoring of carbon monoxide. Carbon monoxide is known as one of the earliest forms to detect something's taking place. There are a couple factors of carbon monoxide. One, it's not about the instantaneous level that all of a sudden it gets to X parts per million and everybody jumps and reacts. It's really about understanding the increases. Often it will take time before it gets to that explosive range. And if you're monitoring the trends, you can detect something's developing sooner, act on it before the conditions worsen. So there is the methodology out there to detect. And then it gets into, oh, what do we do when we detect an issue? But we said that one of the issues is surface tension. One of the merits, F500, the encapsulator agent, reduces surface tension. So it can flow in and around and about those tiny particles, those very porous materials, much more effective than anything. But we also know that when you're dealing with deep-seated fires, the more effective way is to have the equipment and have the encapsulator technology, the F500 agent, that you can use in cooperation with the piercing rod that allows the ability to get down to where the challenge is sooner, faster, better, with least risk, to be most effective in controlling the hazards, not only the fire hazards, but also controlling the vapor, because do recognize carbon monoxide can be an explosive gas. And the piercing rod is a wonderful instrument for deep-seated fires to get to it sooner, faster, better, and safer for everyone, and get that agent in there. Used often on bins, bunkers, silos, hoppers, those types of deep-seated situations works most effectively. Dust collection is another hazard that we're faced with. And this relates not just to coal or biomass, but in other industries. Any industry that uses dust collection for the purpose of collecting those particulate solids and dust that can be combustible or explosive. And that may be everything from sawmills to sawdust to activated carbon to coal to magnesiums and titaniums and various types of the class A and D types of hazards out there. Dust collection is one of the technologies that's used. But often dust collection systems are not properly designed for the hazards. And yes, there are criteria to properly design them and criteria to properly operate and maintain them. But what we continue to see that many of them are the result of an explosion, where the combustible dust being processed ends up, whether it's an exothermic chemical reaction, whether it's some form of ignition, its exposure then generates the heat and ultimately have the conditions for the explosion to happen. And those continue to happen too frequently in the world today. And yet there's technology out there to detect it. And there's technology like the F500 encapsulator agent to address it and deal with it very, very effectively. And this is not just coal and biomass. This can extend into many other industries, including agriculture. Rarely do we see a week go by that there isn't a grain dust explosion somewhere, or soybeans, or whatever. So the applications are very broad and very effective in so many things that we do, whether it's an industry or in a community. And that we do know that the F500 encapsulator agent, through a concentrate control supply system using the open nozzle design, can be most effective within dry dust collection systems and to control the hazards without the hazards of people opening them up. Unfortunately, sometimes firefighters open up dust collectors and they're lucky that they don't get the blunt end of the explosion, and sometimes they have lost their life by doing so. Conveyors are another type of fire, the transportation. And again, this is with any type of combustible material. You'll see examples in the video. That is a conveyor of a fire traveling across a conveyor. It travels extremely fast, faster than traditional sprinkler systems can act and react to, let alone control. Then you have the results of it. You have the failure of the equipment, the loss of the equipment, the loss of being able to move the product to where it needs to be. All of that at a significant cost, and sometimes with life loss or injury. Sometimes it's a result of the spillage, sometimes a result of mechanical failures. But the point is, these fires travel very quickly and can be very devastating quickly. Another thing as we talk about coal, that there is a system that is available known as MilPro. MilPro is a very effective system in detecting changes that are developing within pulverizers and mills. And it can grasp that something's happening and act on it before a human being can even detect it, let alone act on it. And this system, MilPro, is a very effective system in the prevention of explosions, fires that ultimately result in significant damages and loss of generation or business interruption, and is another proven technology that is available using the encapsulator technology basis. This is a topic that I could spend many hours on. It certainly is a passion that I share, and this is in the topic of combustible dust. As we recognize in the world today, there are particulate solids.
If it ain't too late, would you call?
There is coal, there is wood, there's aluminum, there's agricultural products. There's many different products out there today that as they become in finer particles size, they become a dust and they are combustible. Many of them are explosive. And over the years, we have taken so much for granted that almost everywhere in our communities and in many of our industries and factories, not just power generation, there is combustible dust present. And it's just a matter of luck if some people get away, never have a flash fire, or explosion. And yet those that have had very bad ones. Some of you recall the Pure Sugar fire that kind of shook the world apart, saying, how can that happen? And that. The National Fire Protection Association has numerous standards on combustible dust. They are currently in the process and soon will be releasing for public input on the new standard called NFPA 660. It is the consolidation of a number of the combustible dust standards into a single standard or code on combustible dust. But that gives the foundation. How do you manage this hazard safely and healthy? How do you do that? Because we know combustible dust exists and it's all around us. It's in the farming communities, it's in the agriculture communities, it's in the wood industry, it's in the power generation, it's in all around us today. And the 5 elements that you need to have an explosion is fuel, something that can burn. That's a lot of that around us. Oxygen, plenty of that's in the air. Some of it's even within the material, like coal has a very high oxygen concentration because it has a lot of moisture to it, a lot of water. An ignition source, and remember the ignition sources aren't always hot work and electrical and that. They can be the chemical reaction that occurs between them in the woods and in the coals, as an example, some of them have a very high moisture content. When they dry out, they lose their moisture. They want to regain that moisture content that is normal for them. And in the reabsorption of moisture, whether that moisture comes from humidity in the air, whether it comes from water someplace or water being applied to it alone, it can actually absorb moisture from each particle in that. It creates an exothermic correction action that generates heat. Thus, spontaneous combustion starts. So the ignition source always isn't something like a match or a torch or a cigarette or a cigar. It's sometimes a chemical reaction that occurs. And you put all of that inside of a containment, whether it's a dust collector, whether it's a bin, whether it's a hopper, whether it's a silo, whether it's a box. You put it in a confined volume and it becomes airborne. It's suspended in dust. All the conditions for an explosion to take place. And yet we know that these are preventable, often by keeping at least one of those elements, just like the fire tetrahedron, away from the others. The real issue with a lot of the combustible dust is not the initial or the primary explosion, but rather the secondary. The secondary explosion generates more airborne dust. It provides more fuel for the flame front to pass through, shaking up more things, making more hazards, and increasing the severity of the situation. So it is something that is very broad, not necessarily very narrow and such. As we get into managing combustible dust, whether it's doing an observation, whether it's preparing to deal with a fire somewhere that may be in or around the facility or the hazard, or actually responding to a situation, one of the first and foremost actions we begin to put in play is what some call the reversed hazards mitigation. Some call it the reversed hazard or hazard elimination. It's addressing all the dust that may be in places undesired. It may be on the structural steel. It may be on lights. It may be on the floor. It may be on process equipment. It's all these different areas that we don't think about because we're focused on the area immediately where the problem is. It's all these surrounding and adjacent ones that can really be the recipe for disaster. So the operations are stopped. Activities go to inspect for and to look for these combustible particulate solids and dust in these different areas. Then becomes the activity to remove them, take them away, clean them. And there's different technologies, and one of those happens to be a product called Dust Wash that can help clean the dust from areas, especially where they're very difficult to reach. And there are other technologies and other methodologies to do that. But in applying the coating of the F500 encapsulator agent to the bulk surface materials, again, to help mitigate dust and to continue to monitor for carbon monoxide and temperatures continuously. Those are some of the very front end things when things just are not right or you suspect a problem is developing. But remember, all of this requires equipment. It requires knowledge. It requires training. It requires humans that have access to the right equipment, humans that have the knowledge to safely understand and react to the situation when things can't be and are not prevented. Let's take just a moment for a few moments. Heather, do we have any questions that are coming in?
I haven't seen any come in just yet, but if anyone would like to write a question either in the chat or open their microphone and ask their question, please feel free.
I certainly welcome any questions or comments at any time. Anyone have anything they like to ask at the moment?
Bob, Graham Higgs in Australia. How are you, mate?
Well, hello, my friend. Doing well.
Excellent. Bob, nuclear is beginning to get a bit of conversation down here. We haven't got any nuclear plants at all, but I think we'll probably see it in possibly in our lifetime. Is there anything, have you had any experience that's unique in nuclear plants that where we would fit uniquely and well at all?
The one topic I do not know about is the nuclear fuel itself, the radiation hazard. That's outside of my understanding. But what we do know about nuclear plants is that they will have fuels. They will have lubricating oils. They will have transformers. They will have bulk supply of materials. It may be diesel fuel, for example, for a diesel fire pump. It may be diesel fuel for an auxiliary boiler or some type of fuel for auxiliary boiler. They will definitely have lubricating oils that are going to be under pressure, and they are definitely going to have transformers. In those cases, a nuclear plant has the similarities to most other facilities in the point of having the Class B fire hazards. Many of them are going to be, again, 2- and 3-dimensional fires that foams will not effectively control, and dry chemical and others will not. And same with transformers, they're going to be those atomized droplets of combustible liquid becoming airborne, the vapors, ignition. And so in my point being is that there is similarities, and one of the greatest similarities is that dealing with the transformer hazards as well as the lubricating oil hazards. Graham, does that answer the question?
It does, Bob. Gives me a lot to think about there, and appreciate your thoughts, mate, and your insight. Thank you.
Yeah, I honestly do not know about the radiation hazard with the fuel. Yeah. That's outside of my my understanding. So, thank you.
We actually have a question from Constantine, who is actually sent as a direct message, asking generally, how long does coating a surface provide level of protection?
Coating of the surface is not necessarily a protective factor. It is more of a factor to mitigate some of the dust during the activities and to help lessen the shift of the product from too much airborne dust. I can't really define a timetable. A lot of the time, how long that will be of effectiveness is going to be based on the size and of the particles, the configuration. There's just too many factors to put a timetable to it. The primary focus is that you clean all the surfaces above that area, and you get a coating on there to help control the dust from that. The one thing I would mention is at one time the thought process was that you would put a blanket of foam on top. The realization is that when that's being done is, number one, it's very difficult to maintain that blanket over a short time, let alone a longer time. The second thing is it doesn't really capture the dust. It doesn't have that bonding ability to the dust particles because it's not reducing the surface tension. It's not basically getting in the pores and around the surfaces. And second of all, it can actually trap in the explosive gases like carbon monoxide. Whereas we do know that the encapsulator agent F500 actually has the ability to encapsulate some of those gases, has the ability for the surface tension reduction to get in and around. But unfortunately, I don't know there's a timetable. A lot of that's going to be based on factors of the product and factors of the configuration in a matter of time. So in other words, I really don't have a good answer for the question.
Bob, Graham again. The question I've been asked is if we do apply F500 to, say, a coal pile, whether it be through maybe a piercing rod or just putting out a hot spot somehow, is that coal then lost to use, or can it just can it be continued on the conveyor belt and so on?
It is not lost. So it is at some given time that has to be decided. It can be basically useful. So it can be sent to the boiler. What you don't want to send is you don't want to send hot coal to a boiler. You're just asking for a disaster. So the piercing rod and the use of technologies like thermal imaging and part of the knowledge you learn in some of the training programs that are available is that the F500 encapsulator agent's not going to cause the product to be a waste product. It can be reused and of value. There are facilities that are using F500 encapsulator agent to basically mitigate some dust and to help reduce spontaneous combustion so that it can safely be used in that. It's just going to be a matter of somebody evaluating that it's still not a high temperature that it could ignite a dust cloud. So it's not a waste product at that time. It's still a very usable product. And the boiler won't know the difference. When it gets to the boiler, it's not going to be bothered by, hey, somebody put a little F500 on this coal. The boiler doesn't care. The boiler will deal with it. Okay. Well, let's talk about some other common hazards, pressurized liquid transformers and such for a few moments. And again, if you have questions, feel free to throw them out to us, and we'll have some more opportunities for conversations. Pressurized liquids and oils are a significant hazard, and those are in coal plants, they're in gas combined cycle plants, they're in nuclear plants, they're in hydroelectric plants, they're in most everything out there today, and not just in the power industry. Many facilities are using some types of pressurized oils for machinery lubrication or such. In typical plants, they're used for the turbine lube oil. The boiler feed pump has a lube oil system, and both of these systems have a large reservoir. Typically, those reservoirs of that lubricating oil are somewhere near the actual equipment, process equipment. There's piping transferring the liquid to the process equipment for its lubrication or for its cooling. Some plants use oil, and they pipe oil into the boiler to establish a fire and to heat the boiler so that when the coal is being delivered initially, that it ignites the coal and sustains a flame there. So they may have an oil ignition system. Some actually use diesel generators and other types of fuels for either black start. In other words, hey, we got to get this, we need to produce some steam, we got to get everything up and running. or they use it for the purpose of generating power or steam initially to do that. So pressurized liquids are very common in many industries. One of the factors that happens is that these, when they fail, they are generally under pressure. The oil will become atomized, very fine particles very quickly. If it hits an ignition source, that could be just a hot steam line, a steam pipe somewhere. It can be a devastating, fast-moving fire and a three-dimensional fire. So now you have running liquid, you have it under pressure, and all the things like, oh no, what do I do? Oh, you mean to tell me that that foam doesn't work? And the answer to that is yes, that is correct. Firefighting foams are not for and three-dimensional scenarios. They're bubbles. They make a bubble over a surface and temporarily, for limited time only, limited showing only, separate the air from the fuel. They do nothing in three-dimensional. It runs right off. You can't build a blanket on a three-dimensional item. And so it has become a topic of discussion. In fact, if you look at some of the research, if you look at some of the standards today, they'll say, oh, some people have used water and they need a lot of water, whereas if they use F500, they need less liquid, and it's more effective on three-dimensional, two-dimensional, and the whole 9 yards, and we can use less of things. So these are fires that happen in so many places, not just power plants, but they would cover certainly a big area of them. The three-dimensional fires, again, are often thought of in the power industry with the lubricating systems, and recognize that often these lubricating systems are providing lubrication to the turbine generator, bearings in both of those, as well as the pipings underneath them. So if there's a loss of piping, containment can be a serious event, as well as generally on the hydrogen, it's going to be available on the generator side as another hazard, and then the boiler feed pump. So all of these things together, you're dealing with stuff that is intended to lubricate some of the most expensive, longest lead time to replace within any given facility. So you're dealing with the equipment that is big bucks and makes big bucks. And the fires, it doesn't take much. It can just absolutely wipe out the facility in just a second or so. So again, as we talked about three-dimensional fires, NFPA 850, which is a standard, or excuse me, is a recommended practice for the electric power generation sector. It gives some specific sprinkler design densities. It recognizes that water may not be the most effective on it. It cautions people over boil over, where you get the water and the oil, and the water heats up and starts to boil and accelerates the spilling or the release of the combustible liquid fire. We know foam traps in heat. It's not a great cooling capability. It's difficult to maintain a blanket on and it just doesn't work on three-dimensional fires at all. And we know the encapsulator agent F500 encapsulates the hydrocarbons. Therefore, they're not ignitable. They're not flammable. It has that tremendous heat reduction ability without producing steam and that. And it works wonderful on three-dimensional fires. And it can be used again on multiple classes of fire, not limiting itself. So it's working on a molecular level. It's working on attacking all 4 angles of the fire tetrahedron, and it's working on multiple classes of fire. And at the end of the day, it can improve the human performance component that often makes a difference between success and failure, from life or death, from damage to property, from business interruption to the environmental components and that. So this is basically an example of some testing that was done by a third party. They used F500 on a 3-dimensional liquid fire at 0.20 gallons per minute per square foot. It extinguished the fire 3 times faster than the recommendation that exists for water today of 0.40 gallons per minute per square foot. It reduced the heat tremendously better. It extinguished the fire, encapsulated the vapors, and it certainly is, for those that are beginning to look at what do we do to replace our AFFF or our fluoroprotein fire systems for our lubricating oil systems, it certainly makes the eye open up saying, oh, I think I have the solution. It's called F500 encapsulator technology.
Hazard Control Technologies presents F500 encapsulator technology.
Lights the building. Hey, go, bring it! Hey, a little bit longer than a door will fall off. Yeah. We got a good picture, man. 441, we're hooking up another line.
So we can see that transformers are another example that are the need for the F500 encapsulator technology on, again, 3-dimensional, generally are energized, with a lot of significant hazards and harm. And they're in every community. They're on poles, they're on the ground, they're different sizes. And it's one of the hazards that almost every one of us, whether it's the fire department or the industry, we're faced with at some time. And the challenge that we have, and yet we now have the technology and the understanding to be able to mitigate these hazards should they occur. Again, you have to have it, you have to have the knowledge, you have to have the equipment, you have to have the technology to be truly effective. So it's one of those things you can never be overly prepared for.
That was amazing. Just think if a motherfucker was up in there.
Hazard Control Technologies presents F500 encapsulator technology.
We're at the Philadelphia Electric Company fire training grounds where F500 is being used to extinguish an electrical transformer fire. F500 is fed at 3% into the sprinkler deluge system utilizing 10 5-gallon per minute heads. The fire is quickly knocked down to include the running surface fire by the indirect spray from the heads.
Hazard Control Technologies presents F500 encapsulator technology.
We're at the Philadelphia Electric Company fire training grounds where F500 is being used to extinguish an electrical transformer fire. F500 is fed at 3% into the sprinkler deluge system utilizing 10 5-gallon per minute heads. The fire is quickly knocked down to include the running surface fire by the indirect spray from the heads.
So there are some examples of case studies, and there are more than just 2 of them out there. One, this is a transformer at a generating facility. They had a F500 encapsulator agent concentrate supply system, control supply system on there, again, using F500 at 3%. Fire was totally controlled in less than 3 minutes and 10 seconds without any firefighters. They used about 3 gallons of F500, less than $100, very little cleanup cost. Compared to another similar in design and size of equipment, 6 hours to extinguish, 2 fire departments, 400 gallons of AFFF, 50,000 gallons of water. Somewhere in the cleanup area of $8,000 just for the AFFF cleanup, and how knows how much it was for all the water that had to be contained, cleaned, and so forth. So all of a sudden, spending a little bit up front to be prepared pays off hugely should something ever develop in that. So there's a couple things to think about. The encapsulator agent sometimes is applied through an F500 concentrate control supply system, commonly on transformers, turbines, lubricating oil systems, some of the key co-handling areas like conveyors, dust collectors, energy storage systems, lithium-ion battery systems, and that. Some have used it in a portable mode that they can basically have F500 in a bulk supply on a trailer or a truck and be able to locate it where they need it at given time and be able to introduce it in with water at the proper concentration and the proper equipment to move that about. And again, this isn't just limited to power generating facilities. It can be used as a direct application on transformer fires. The thing that I will encourage state that it can be used on energized equipment with the proper training, understanding of the hazards, and the techniques to apply to protect yourself from any feedback or electrical concerns. So it can be applied on those, and there are examples after examples that can be shared with you on just doing that. And it works most effectively on these types of scenarios. So what we're seeing today, at least in some areas, is some demanding hazards are rapidly developing. And they're happening so fast that we can't overlook that these hazards are emerging, they exist, and preparedness and planning and equipment and technology and training need to be in place if we're going to protect people, protect property, minimize business interruption, and be environmentally responsible. And these are the 3-dimensional pressurized oil hazards. The energy storage system are starting to really blossom. Lithium ion is here, and it's increasing. Yesterday, I had the pleasure of being at a police academy and doing just an awareness on electric vehicles, and they were all like, oh, we never knew that these vehicles had these types of hazards. We just thought they were like, the traditional gas. You just have a switch someplace you have to pull and de-energize them. These are real hazards that are emerging today. Combustible metals are in and around us today. We're driving them. We have them in our homes. We have them with our electronics. We have more and more of them in our communities today. These are today's and tomorrow's emerging and demanding hazards. The one thing that is a common with all of them is the
Hazard Control Technologies
to
presents
safely handle them
F500
is the
encapsulator
F500
technology.
encapsulator technology.
In November 2015, one of the recycling buildings belonging to Inmetco, the International Metals Reclamation Company, burnt to the ground. Inmetco is a big recycler of lithium-ion batteries. The batteries started the fire, which spread into other areas. Firefighters worked on other materials in the building but could not extinguish the batteries. They needed a solution.
You don't have a screen. Okay, you got it now. Yeah, it's
like he's put 20 gallon a minute on, and would he have it on for less than a minute? He's not even putting 20 gallon on his fire. When you have a sprinkler system go off, some of them nozzles.
Yeah, you may have a 20 gallon from the head. There you go.
Officials from Inmetco were on hand to witness the power of F500 encapsulator agent on lithium-ion battery fires. The assorted batteries provided by Inmetco included both lithium batteries and lithium-ion batteries. The lithium batteries are a Class D combustible metal fire. Applying plain water to lithium will create explosions as the high temperatures cause the hydrogen and oxygen to separate into explosive gases. Also, water evaporates to remove heat, which is very inefficient. Adding just 3% of F500 encapsulator agent forms a protective skin around the droplets, preventing evaporation and causing heat to be absorbed. F500EA can be applied directly to Class D metal fires without dangerous flare-ups or explosions. The heat is rapidly absorbed.
Now or you want to wait for a while? Good. Let it burn. You want to burn? By the time you guys get here, they're ripping. All right, hold up a second. That's fine. Just making sure I got it.
You can see and hear the batteries exploding.
Straight as you can get her from a distance and try to knock her down. Another inch in the face.
Sounds like you're ready.
All right, good.
We got a sprinkle nozzle going down in here now.
Using a TKO nozzle at 20 GPM, the fire was out in just over a minute and used less than 2 quarts of F500 encapsulator agent.
I'm just going to go bottle.
How many gallons is that gonna be?
20 gallons a minute. I don't know if anybody's timing how long it's been. Yeah, your camera is.
Oh, not it hasn't been. You know, I'm thinking of a sprinkler nozzle now.
I don't see any smoke anymore on this. The explosion's off. That's all that matters.
Yeah.
We couldn't stop the explosion. Yeah, give her another 500.
The true words of a fire instructor: let it burn. Got to get it a little bit hotter. So again, that's an example of the technology on today's greater emerging hazard in almost every community and all around the world, the lithium-ion battery scenarios in the energy storage systems. Just to point out a couple of the services, Hazard Control Technologies is a full service fire and hazard provider. They provide consulting services in everything from co-handling or bulk material to dust hazards analysis to emergency preparedness and planning and response planning to training courses, again, on combustible dust, to bulk storage, to co-handling, and a list of other areas that are available.
Where is the moment we need it the most? You kick up the leaves and the magic is lost. Tell me your blue skies fade to gray. Tell me your passion's gone away, and I don't need no carrying on. Stand in the line just to hit a new low. You're faking a smile with the coffee to go. And tell me your life's been way offline. You fall into pieces every time, and I don't need no carrying on. 'Cause you had a bad day, you're taking one down.
It is with hopes that none of you have a bad day, is that understanding the hazards and understanding that there is encapsulator technology there to make a positive difference are critical to making your day a better day. Better because no one got hurt, better because no one is imposed to ill health effects, better because hopefully you work with great people and had a good interaction and had some laughs, and the reality of when many people work is for a little bit of money. So the point is encapsulator technology helps you understand the hazards, helps you address the hazards, but it does come with the proper knowledge, the equipment, and the preparations for. And these hazards that are here today and that will be here tomorrow can be managed safely and healthy. With that, any questions or further comments?